These notes are for AP Calculus on showing how to find the derivative using the quotient rule. I don't think anyone finds the quotient rule fun. You have to be very careful. There's a lot of places you can make a mistake. Later on, once you get good with all the different rules for finding derivatives, you might want to manipulate equations so you can avoid the quotient rule. But I do need to teach you how to use the quotient rule to begin with. There's some instances where you just cannot get away from using the quotient rule. So the quotient rule looks complicated. You just have to be very careful. You can do it. We're going to take the derivative of a quotient. That means polynomial divided by another polynomial. I've got this stuck in my head. It had been over 20 years since I had done calculus, and it came right back to me, like riding a bicycle. I'm going to take the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator. All of that's divided by the denominator squared. So in my head, I say bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. It's boring. There's other ways to do it. Very common way is to say low d high minus high d low divided by low squared. What that means is low is the denominator, derivative high, derivative of the numerator, minus high, which is numerator, d low, derivative of the denominator, divided by the denominator squared. So let me go ahead and go through some of these examples. If this is f of x, 3x squared, and this is g of x, and I want to find the derivative with respect to x of f of x over g of x, I'm going to take the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator all over the denominator squared. With the product rule, it did not matter the order that you took the derivative because you were adding. In the quotient rule, it's a huge difference. If you don't do these in the right order, you're going to have the negative in the wrong space. So I'm just going to clean this up a little bit. So I have the derivative with respect to x of f of x over g of x. It's going to equal 6x squared plus 30x minus 3x squared over x plus 5 squared. I don't ever multiply the denominator together. It doesn't serve any purpose at all. I'm going to leave it like that. The only other thing I can do is I can clean up the 6x squared and the 3x squared combined like terms. So I have the derivative with respect to x of f of x over g of x equals 3x squared plus 30x over x plus 5 squared. If I wanted to, I could factor out a 3x and I'd be left with x plus 6. That doesn't get me simplifying anything. So I'm going to just stop right there. Nothing wrong with it. My next example, example 4, I've got, and the reason this is example 4 is because this is coming off of the product rule sheet. I used to put these all together. This year I split them up. So I've got a quotient, 4x minus 7 over x squared plus 9. So my derivative, x squared plus 9 times 4 minus 4x minus 7 times the derivative, so 2x over x squared plus 9 squared. Clean up just by multiplying. I get 4x squared plus 36 minus 8x squared plus 14x. And be careful here. This was negative 7 times 2x gives me negative 14x, but this minus sign in front has to get carried. If people make a mistake, that's usually where they do it. And then I'm going to combine like terms. I have a 4x squared and a negative 8x squared. So I get negative 4x squared plus 14x plus 36 x squared plus 9 squared. I could factor out a 2, which gives me 2x squared, negative 2x squared plus 7x plus 9. That doesn't factor down anymore. I'm just going to stop right there. Okay. Each one of these is a little bit different now. So I've got, fifth one, I've got f of x equals 1 over x minus 5. I could write this as x minus 5 to the negative first power, and I will later on to show you that there's another rule that we can use. But for right now, I want to show you this with the quotient rule. So the derivative is going to be the denominator times the derivative of the numerator. The derivative of the numerator is 0. Minus the numerator times the derivative of the denominator all over the denominator squared. And I do look for this. When I'm looking at your papers to grade them, I'm looking at your showing each steps. I do not recommend taking shortcuts with this. It's too easy to make a mistake. When you take the AP test and you're doing certain things, you cannot show shortcuts. They want to see that you understand processes. So that's the first step. If you shorten it from there, just that's got to be your first step. So f prime of x, x minus 5 times 0 is 0. Negative 1 times 1 is negative 1. So the numerator is negative 1, denominator is x minus 5 squared. So you can see there is a shorter version to get from here to here, and you might be able to figure it out, but later on I will show you. If you want to look into it, just look up the chain rule, and that's what we're going to be doing pretty soon. Okay, here's the next one. Another quotient rule, because I have a numerator and now I have a denominator. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And I would go back and double check. Low, derivative of high, minus high, derivative of low, divided by low squared. Clean it up. 5x squared plus 5 minus 10x squared minus 4x and a 9 is plus 4x over x squared plus 1 squared. Combine like terms. So I get negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Okay, on the back, I picked each one of these to show you something specific. So the first one I'm going to do, I'm going to do it a couple different ways. I'm going to use the quotient rule first. Then I'll show you an alternative way. So I've got the derivative of y with respect to x, low, d high, minus high, d low, over low squared. Go ahead and distribute. I get 96x to the fourth plus 20x squared minus 64x to the fourth minus 40x squared or 16x to the fourth. So 96 minus 64 is going to be 32 x to the fourth. 20 minus 40 is minus 20 x squared over 16x to the fourth. Now if you notice, I can factor out. I can factor out, let's see, 4 goes, 4 should be the common term, x squared. So this gives me 8x squared minus 5. And if I take a 4x squared out of the denominator, I'm left with a 4x squared. 4x squared over 4x squared is 0. So the answer becomes 8x squared minus 5 over 4x squared. Now with this one, there is an alternative we could do. And I found a lot of students feel more comfortable doing this. Notice my denominator is only a monomial. It's only one term. So it's almost easier to think of this. Let's say I had 8x cubed over 4x squared plus 5x over 4x squared. This is going to give me 2x plus 5/4 x to the negative 1. If I take the derivative of that, I get, we can move up to here, 2 minus 5/4 x to the negative 2. 2 minus 5 over 4x squared. If I get a common denominator, multiply this with 4x squared here, there's a 1 here, 4x squared, 4x squared. 4x squared times 2 gives me my 8x squared. Minus 5 over 4x squared. So later on, you know, as you get better at these things, you might want to change how you do this, whichever way you see it better. It doesn't matter. I'm not going to tell you that you have to do it one way or the other, as long as you can do it correctly. Okay, so here I could do the same thing. I could go ahead and say, well, this is equal to 3/5 x squared plus 8/5 x minus 2/5. So if I do the derivative of that, I get 6/5 x plus 8/5, which is going to give me 6x plus 8 over 5. Well, I could do that using the quotient rule as well. So I've got low d high minus high d low. The derivative of the denominator is going to be 0 over the denominator squared. This is all 0, but now look at this. This 5 and this 25 is going to reduce to 1 over 5. So right away, I get 6x plus 8 over 5. I get the same answer, so it just depends on which way you see it best. This next one I like. We just did, hopefully you do the trig derivatives first and then you come to this, but this I can show you how this trig works with this. So if I use the quotient rule, because I have sine as a function over the cosine, so it's a quotient. So derivative, low d high minus high d low over low squared. So cosine x times cosine x is going to be cosine squared x. Negative sine x times negative sine x is going to be positive sine squared x. Cosine x squared is just saying cosine squared x. If you remember Pythagorean identity, sine squared plus cosine squared is equal to 1. So I'm going to replace this cosine squared plus sine squared with 1. Keep going. 1 over cosine is secant. So 1 over cosine squared is secant squared. So this tells me y prime is equal to secant squared x. Alternately, if you came back up to here and recognize sine x is equal to, or sine x over cosine x is equal to tangent x, and the derivative of tangent x is secant squared x. I remember being told you don't have to memorize all the tangent, cotangent, secant, cosecant. As long as you remember sine and cosine, you can figure out all the other ones. Sometimes it's more work, but it works every time. Same thing is going to work here. I have f of x equals 1 over sine x. So f prime of x, if I use the quotient rule, low d high minus high d low over low squared. Sine x times 0, 0. So minus 1 cosine x. So f prime of x equals minus 1 cosine x. Actually, I don't need to write the 1. Over sine squared x. Now let's just do a little bit of manipulating. I could say this is equal to negative cosine x over sine x times 1 over sine x. Cosine x over sine x is cotangent x. So this is going to be equal to negative cotangent x. 1 over sine x is cosecant x. Go back to up here to the top. 1 over sine x is going to equal cosecant x. Derivative of the cosecant of x is equal to negative cotangent x, negative cosecant x times cosecant x. So once again, you can figure it out. So quotient rule, be very careful. It's not hard, but there's many steps that you can make a mistake. Go slow, write neatly.